Hello and welcome to a lesson on completing the square. This lesson is for both higher tier GCSE students and for A-level students. We look in detail at completing the square for the quadratic function and show how it can be used to identify the line of symmetry of a quadratic graph and the turning point coordinates of that graph. Once we've looked at several examples on that theme, we'll show how you can use the completing the square technique to solve quadratic equations. Completing the square. For quadratic functions, completing the square is about writing the general quadratic function y equals ax squared plus bx plus c in the form y equals a multiplied by x plus p all squared plus q. Now here a, b, c, p and q are any numbers. We will find that the a's will match up, but the p and q will certainly not be the same numbers as b and c. Now at this point you might be wondering, why would we want to do this? Why would we want to write the general quadratic function in this form here? Well, I hope to illustrate that as we go through. So let's begin by considering x plus p all squared. What do we get when we expand that bracket squared? The bracket times itself, and we get x times x is x squared, x times p is plus px, plus p times x is plus px, and plus p times plus p is plus p squared. And then we can collect plus px to give us plus 2px. And that's going to give me the relationship I need to link the amount of x's I have to the number that goes in the bracket. So let's have a look at an example now. Let's say y equals x squared plus 6x plus 5. If I'm going to write that in the form x plus something squared plus the 5, what's going to go in this bracket? Well, if we look down here, we can see that the number of x's here is twice as big as the number that would have to be in the bracket. So the number that will have to go in this bracket will be half of plus 6, so it will be plus 3. Now the question is that the same as that? Well, no, it isn't, because we can see down here it also introduces this p squared term. So let me show you. If we have x plus 3 multiplied by x plus 3, that gives us x times x is x squared, x times 3 is plus 3x, plus 3 times x is plus another 3x, so that does give us the plus 6x we want, but it also gives us plus 3 times plus 3, which is plus 9. So instead of just replacing these two terms here, I've introduced an extra plus 9. So I need to subtract that plus 9, so it has to be minus 9 on the end. And that then will make this expression the same as x squared plus 6x plus 5. And I can rewrite that as x plus 3 all squared and plus 5 minus 9 is minus 4. So I've now written this in an alternative form. But what was the point? How has that helped us? Let's have a look at autograph to see what's happened to the graph. If we start with the graph of y equals x squared, then I can change that by a translation along the x-axis and a translation in the direction of the y-axis. So let's put in there x plus 3. And what happens to the graph? It moves 3 units to the left. So we've now got a line of symmetry at x equals minus 3. Let's change the graph again. Let's put on the end minus 4. And what has that done? That's moved the graph down 4 units. So I've now got a line of symmetry at x equals minus 3, and I've got a minimum point here with coordinates x is minus 3 and y is minus 4. So going back to our page here, what we can see is we get a line of symmetry at x equals -3. And we get a minimum point with coordinates x is -3, y is -4. So writing the function in this form enables me to identify a line of symmetry at x is -3, and it enables me to identify the coordinates of a minimum point. And that's the point -3, -4. So notice that we've got a sign change there. It's not the same sign as that +3 because it's the value of x that makes the bracket 0. But the y coordinate is actually given by this number here. We don't change the sign of that one because when x is -3, this bracket is 0, so the bracket squared is 0, and y is simply -4. Let's have a look at a similar example, but this time we'll have a negative amount of x's. So we'll say y equals x squared minus 8x plus 18. So to complete the square, I want x with some number in there squared plus 18. What number is going to go in here? Well, if we have a look at when we expand x minus p all squared, you'll find that we get x squared minus 2px plus p squared. So this number on the end is still positive because minus p times minus p gives plus p squared. But the number that's going to go in the brackets is half the number of x's again. So half of -8 is -4. But that doesn't mean that this expression on the right is the same as that expression there, because if I multiply out x minus 4 multiplied by x minus 4, then what I get is x squared minus 4x minus another 4x is minus 8x, which is what I want, but it introduces this term on the end of minus 4 squared. Minus 4 times minus 4 is plus 16. Now I've already written in the plus 18 again, so I'm trying to replace x squared minus 8x with something, but I've replaced it with x squared minus 8x plus 16. So I need to take that 16 back off, and that will always be the case. I'm always going to subtract the square of this number here. So y is equal to x minus 4 squared, and plus 18 minus 16 is plus 2. So let's have a look at autograph again, and we'll set up the graph of y equals x minus 4 squared plus 2. So starting with the graph of y equals x squared, we'll transform it by saying x minus 4 squared, and that moves it 4 units to the right. And then we'll change it again and we'll put in the plus 2 on the end, and that will lift it up 2 units. So now we see we have a line of symmetry at x equals 4 and a minimum point at the point x equals 4, y equals 2. So let's get that drawn in. Line of symmetry is at x equals 4, and the minimum point is when x is 4 and y is 2. So we can identify a line of symmetry here when x is 4 and a minimum point here when y is 2, and the graph looks something like that. So again, to identify the line of symmetry, it's the value of x that makes the bracket 0. So it's the opposite sign to this number here, x equals 4. But the y coordinate of the minimum point is simply this number here. We don't change the sign of that one. When x is 4, the bracket is 0, the bracket squared is 0, so y is just 0 plus 2, which is 2. Notice that's a minimum point in this case because a squared quantity is always at least 0. It's either 0 or greater than 0, and that occurs here. It's greater than 0 there, it's greater than 0 there, but at that particular point it's 0. Let's move on now to look at a summary of that. If we've got y equals x plus p all squared plus q, we can find a line of symmetry for the graph at x equals minus p, the value that will make the bracket 0, and the coordinates of the minimum point will be when x is minus p and y is this number on the end, q. Right, we'll now look at 4 examples of completing the square for quadratic functions, and each one will be slightly more difficult than the previous one as we go through. We're going to write the following functions in the form y equals a x plus p squared plus q. We'll identify the turning point at minus p, q, and identify the line of symmetry x equals minus p. And finally we'll sketch the graph for each example. First example, y equals x squared minus 6x plus 8. We write y equals x in some bracket squared plus 8. Now what goes in this bracket? It's half of this number here, so I want to put minus 3 in the bracket. Now introducing minus 3 in that bracket brings in a term minus 3 squared, which is plus 9, that we don't want. So we need to subtract the 9. And that will always be the case, carrying out a subtraction at that point. So y is equal to x minus 3 all squared, and plus 8 minus 9 is minus 1. And I've now got all the information I need to identify the line of symmetry, the coordinates of the minimum point, and to sketch the graph. So, line of symmetry, it's the value of x that makes the bracket 0. So that's x equals 3. The minimum point is on the line of symmetry, so x is 3, and the y coordinate is given by this value here, minus 1. And that's because when x is 3, 3 minus 3 is 0, 3 squared 0, and y is 0 minus 1. Let's put the line of symmetry in at x equals 3. And the minimum point occurs when y is minus 1. So the graph looks like this. Now it's not to scale this graph, but the general shape is correct. And on an exam question, when you sketch the graph, they're interested in the coordinates of this minimum point, 3 minus 1. They're also interested in where it cuts the y-axis. And we get that by just putting x is 0, because on the y-axis x is 0. So y is 0 squared minus 6 noughts plus 8. In other words, it's 8. So to get full marks, we need to identify the point where it's cutting the y-axis. You're not expected to find the values where it cuts the x-axis in a question like this. Moving on then to example 2. Y equals x squared plus 7x plus 10. Y equals x in a bracket squared plus 10. Now we want half of this value here. So half of 7 is 7 over 2. So it's plus 7 over 2. Leave it as an improper fraction. Resist any temptation to write 3.5. Improper fractions are perfectly okay in this kind of work. Now then, this introduces a square of 7 over 2 that shouldn't be there. So what is 7 over 2 squared? Well, a fraction multiplied by itself, we multiply the numerators, 7 sevens are 49, and we multiply the denominators, 2 twos are 4. So we need to subtract 49 over 4. So y is equal to x plus 7 over 2 all squared. Now put the 10 in quarters. 10 fours are 40, so 10 is 40 quarters, 40 over 4. 40 over 4 minus 49 over 4 is minus 9 over 4. And now we've got what we need to identify the line of symmetry, the minimum point, and to sketch the graph. Line of symmetry is the value of x that makes the bracket 0. X equals minus 7 over 2. And the minimum point occurs on that line, so the x-coordinate is given by minus 7 over 2. The y-coordinate is simply this minus 9 over 4, which occurs when the bracket is 0. Line of symmetry is at minus 7 over 2, so over here somewhere. So minus 7 over 2, and the y coordinate down here at minus 9 over 4, and the graph something like that. We need the coordinates of where it cuts the y-axis. X is 0 obviously, but the y coordinate is 10 when you put x is 0 in there. So we mark on 10 to complete the graph. Example 3. Y equals 2x squared minus 10x plus 13. Now this is our first example with more than one x squared involved. So how do we tackle that? Well, what we do is we take out a common factor of the number of x squareds we have. So y is equal to 2 multiplied by some bracket. Now you may be thinking, but there isn't a common factor of 2 running through these three terms. Well, we just forced the issue to make a common factor of 2. 2 multiplied by x squared gives me 2x squared. 2 multiplied by minus 5x will give me minus 10x. And 2 multiplied by plus 13 over 2 will give me 13. So I allow myself to have improper fractions involved in the bracket. Now let's complete the square within the square bracket. So y is equal to 2. If I'm completing the square here, I want x in a bracket squared plus 13 over 2. Leave enough space to do the subtraction on the end. What number goes in here? Half of the minus 5. So it's minus 5 over 2. Now that introduces a term of minus 5 over 2 squared. Minus 5 over 2 times minus 5 over 2 is 25 over 4. So I need to take that 25 over 4 away from what we've got. So y is equal to 2 multiplied by x minus 5 over 2 all squared. Now what have we got here? Let's put it on a common denominator of 4. 13 over 2 is 26 over 4. 26 over 4 minus 25 over 4 is plus 1 over 4. And now I can remove the square brackets. Y is equal to 2 times x minus 5 over 2 all squared, and 2 times plus a quarter is plus a half. And now we can identify the line of symmetry. That occurs when the bracket is 0, so x is 5 over 2. And the minimum point is on the line of symmetry, so the x coordinate is 5 over 2, and the y coordinate is just this plus a half. So what we see here is the 2 at the front does not affect the line of symmetry, and it doesn't affect the coordinates of the minimum point. When x is 5 over 2, the bracket is 0, so the bracket squared is 0, but 2 times 0 is still 0, so y is still just equal to this number here. What we would get with a 2 there is a steeper graph, and if I was doing a scale drawing rather than a sketch, we'd see a much steeper graph than when we only have 1x squared. Right, x equals 5 over 2 will give me the line of symmetry. So we'll put 5 over 2 in there. And the minimum point occurs when y is a half. Bit more pointy than it should be at the bottom. You wouldn't be penalised for that in an exam, provided you can see it's meant to be curved. And the point where it cuts the y-axis, we can see if you put x is 0, y is 13. And that completes example 3. Our final example is y equals minus 3x squared plus 12x plus 7. Now this time we have a negative amount of x squareds, and you'll notice that I've said here that we have a maximum point, not a minimum point. If you've got a quadratic function with negative x squareds, the general shape is sort of Sugarloaf Mountain rather than a piece of string dangling between 2 points. So the graph is upside down to what we're used to. How do we tackle this one? Well, again, we take out a common factor of the amount of x squareds that we have. So we write y is equal to minus 3 multiplied by a square bracket. What do I multiply minus 3 by to get minus 3x squared? X squared. What do I multiply minus 3 by to get minus 12x? Minus 4x. What do I multiply minus 3 by to get plus 7? Answer, minus 7 over 3. Now we need to have a close look at that. Just convince yourself that this is the same as the line above. There's the minus 3x squared. Minus 3 times minus 4x is plus 12x, and minus 3 times minus 7 over 3, minus times a minus is a plus, 3 times 7 over 3 is 7. So again I've got the improper fraction involved, but also taking out a negative factor has caused sign changes in every term. So instead of having minus x squared, I've got a plus x squared. Instead of having positive x's, I've got negative x's. Instead of having a positive constant, I have a negative constant. So, working from there, inside the bracket to complete the square. Forget about the minus 3 at the front for now. We've got x something squared minus 7 over 3. What's the number that goes in here? It's half of the minus 4, so it's minus 2. Minus 2 squared is plus 4, so I need to subtract the 4. Y equals minus 3 square bracket x minus 2 squared. Now then, minus 7 over 3 minus 4. Put the 4 in thirds and we get minus 12 over 3. So it's minus 7 over 3 minus 12 over 3, which is minus 19 over 3. And at this point, we can take off the square brackets by multiplying through by the minus 3, and we get minus 3 multiplied by the bracket squared. And minus 3 times minus 19 over 3 is plus 19. Minus times a minus is a plus. 3 times 19 over 3 is 19. Right, now to identify the line of symmetry. Same again, it's when the bracket is 0. So it's when x equals 2. And I'll talk a bit more about the maximum point in a minute, but let's identify the coordinates. It occurs on the line of symmetry when x is 2. And the y coordinate is just given by this number here, plus 19. So the minus 3 again does not affect the line of symmetry, and it doesn't affect the coordinates of the turning point. But I say turning point rather than minimum point this time, because in this case it's not a minimum point, it's a maximum point. So let's put in the line of symmetry, and that occurs when x is 2, and the maximum point is up here somewhere when y is 19, and this time the graph looks like this. Where does it cut the axis? Well, if we come back to here and put x is 0 in, you'll see it cuts the axis at 7, at y equals 7. Now, what we've got here, this expression in the bracket that's squared, it's always at least 0. A squared quantity is either 0 or positive. But when we multiply it by minus 3, that positive quantity becomes negative. So this is either 0 or negative. And that's why y's maximum point is at y is 19. Because at all other times, apart from when x is 2, this part here is a negative quantity, which makes y less than 19. And that completes our look at completing the square to identify turning points and identify lines of symmetry. We'll now go on to look at solving equations using completing the square. You may not realize it, but the quadratic formula minus b plus or minus the square root of b squared minus 4ac all divided by 2a is actually derived using completing the square. So we can use completing the square as an alternative to the formula or to factorising to solve quadratic equations. And I'm now going to work through 3 examples to conclude the lesson. X squared minus 2x minus 8 equals 0. If we complete the square on the left hand side, we get x minus 1 squared, taking half of the minus 2, minus 8. Now then, the minus 1 squared is plus 1, so I have to take off the 1, and that's equal to 0. So x minus 1 squared minus 8 minus 1 is minus 9 is equal to 0. And now I take the 9 to the other side, where it becomes plus 9. And at this point, we take the square root of both sides of the equation. So the square root of x minus 1 squared is x minus 1. And the square root of 9 is not just 3, it's plus or minus 3. And that's what's going to give us our 2 answers to this quadratic equation. So x is equal to plus or minus 3. And if I take the minus 1 to the other side, it becomes plus 1. So x is equal to plus 3 plus 1 is 4, or x equals minus 3 plus 1 is minus 2. So the roots of that equation are x equals 4 and x equals minus 2. Moving on now to example 6. X squared minus 3x minus 10 equals 0. Complete the square on the left hand side. X minus half of this number here is minus 3 over 2 squared, minus the 10, and I then have to subtract the square of minus 3 over 2. Minus times a minus is a plus. 3 over 2 times 3 over 2 is 9 over 4, so I'm subtracting 9 over 4. And the right hand side is 0. X minus 3 over 2 squared. Put this into quarters. Minus 10 is minus 40 over 4. Minus 40 over 4 minus 9 over 4 is minus 49 over 4. Taking that term to the other side, we get x minus 3 over 2 squared is equal to plus 49 over 4. And now we take the square root of both sides. Square root of the bracket squared is just what's in the bracket, x minus 3 over 2, and the square root of 49 over 4. The square root of a fraction is the square root of the top over the square root of the bottom. So the square root of 49 is 7, the square root of 4 is 2, but we must not forget it's plus or minus 7 over 2. Just as a check, 7 over 2 times 7 over 2 does give you 49 over 4. So we get x is equal to plus or minus 7 over 2, and when I take the minus 3 over 2 to the other side, it becomes plus 3 over 2. So what are our 2 answers? X equals 7 over 2 plus 3 over 2 is 10 over 2, which of course is 5, or x equals minus 7 over 2 plus 3 over 2, which is minus 4 over 2, and that's minus 2. So the answers, x equals 5, x equals minus 2. One final example, x squared plus 6x plus 2 equals 0. Half of the plus 6 is plus 3, so it's x plus 3 squared plus the 2. Now subtract the square of 3, so subtract 9, and that's equal to 0. So x plus 3 squared plus 2 minus 9 is minus 7. Take the minus 7 to the other side, and we get x plus 3 squared equals 7. And take the square root of both sides, we get x plus 3 is equal to plus or minus the square root of 7. Now it depends whether we're in a calculator exam and want to use a calculator, or whether we're going to give the answer in insert form if it's a non-calculator exam. So from here we can say that x is equal to, taking the 3 to the other side, it becomes negative, minus 3 plus or minus root 7. And it's okay to give the answer like that, or you can split it into 2 by saying that's minus 3 plus root 7, or x equals minus 3 minus root 7. And that concludes this lesson on completing the square. You'll find 2 exercises associated with this lesson. The first uses the technique to identify lines of symmetry of quadratic graphs and the coordinates of their turning points, and the second concentrates on using the technique to solve quadratic equations.